Hello, everybody. My friends from room 208. Hopefully, you're having a good day so far. We're going to go back to line plots again. Hopefully, you did okay in yesterday's assignment. Let's remember that line plots are a way to display data along a number line where each dot represents one number in a set of data. And then we also talked about outliers. Move that over. And outlier, remember, is any number on the number line that is very different from the rest of the numbers. So it gets its name outlier because it's kind of out away from the other numbers. So if we look at this is the one we did yesterday, the lengths of the fish caught. And remember, in any line data, you need to have the title of your line data and then what it is you're using for measurement. So we have inches down here. So if we look at this line plot right here, is there an outlier? Is there an outlier that kind of sticks out from the other numbers? No, I would say not. They're all kind of close to each other. So in this case, there would not be an outlier. All right, so we're going to just do a review from yesterday. We're going to talk about those giraffes again. Those giraffes. So here we have our line plot from yesterday. Hopefully you can see it. Yep. So we have all of the different numbers. So like for 14 feet we have 2 giraffes, 15, 16, then 18 feet we have 2 giraffes too. So each of those dots represents a giraffe. Okay, so in looking at that line plot, how many giraffes are 14 feet tall? Well, all you have to do is go to the number 14 and you can see there are 2 giraffes. What is the most common height? So basically, which of those numbers has the most dots above it? And as you can see, that would be 15. So most of the, I shouldn't say that, the most common height for the giraffes in this case would be 15 feet. And how tall is the tallest giraffe? Well, if you flip over here, you can see the tallest one is 18. There are 2 giraffes that are 18 feet. And is 18 feet an outlier? What would you say? Well, I would say it probably is because it jumps over a number. So these 3 are all right next to each other, and then 18 is one over. So, I mean, you could consider that to be an outlier. It's a number that's away from the others. Sometimes an outlier is way far away. And just real quickly, an outlier can be like if there was a giraffe that was, say, 5 feet tall, well, 5 would be quite a distance away from these. So it doesn't have to be a number that's higher. It can be a number that's lower as well. All right, let's move on. So today we're going to talk about some new ones. So we're going to talk about pencils first. I'm just going to tape that on so it stays. So these are the lengths of Sandy's pencils. Okay, so it has the color and then the lengths. So of course, the other thing I want to talk to you about real quickly is how do you know what to use for measurement in your line plot? Well, let's look. Most of these are in fourths. So we're going to divide our line plot into fourths. So I've done that. And I started with the lowest number, which is right there, 5 1/4. So that's where my line plot, I started with 5 and ended with 7, because you want to start with whole numbers and end with whole numbers. So I started with 5, and then I started counting by fourths. 5 1/4, 5 2/4, 5 3/4, 6, 6 1/4, 6 3/4, 6 2/4, 6 3/4, and 7. Okay, and you also have to make sure your number line or your line plot goes in each direction. It continues onward. So that's why I have the arrows. Okay, so now I can put my dots up on my number line. Just have to find my marker. All right, I'm going to use pink. So as we can see, I'm going to start here, 6 1/4. and I have 1 for 6 1/4. So I've done the red. The blue is 5 1/4. So that represents the blue pencil. The green pencil is 6 3/4. So right here. Purple is 5 3/4. Right here, 5 3/4. The orange is 6 3/4. So that's over here. And then the yellow is 6 2/4. So I'm going to put it above that one. Okay. So now, Sandy's pencils are up on the line plot. So of course you can see the one that is the shortest in inches is 5 1/4 inches. The longest one is 6 3/4 inches. Okay? All right, so that's how you plot your information, your data, on a number line. All right, let me try another one. All right, let's look at this. This is something I'm sure the girls will be interested in because it has to do with bracelets. And I know before all this happened with the quarantine, some of you were making bracelets. So we have Brianna is making bracelets for her friends and family. The bracelets have the following lengths in inches: 6, 6 3/4, 6 1/4, 5 3/4, 5, 6, 6 2/4, 6 1/4, 6, 6, and then 5 3/4. So let's see how many bracelets we should have all together when we finish our line plot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So Brianna has made 10 bracelets in all. So what we're going to do is complete a line plot using the data. So once again, what are we going to count by? Well, we're going to start by the lowest number. So, oh look, 5. 5 is the lowest number, and it goes up into 6s, and so we're going to start with 5 and we're going to end with 7, and it looks like they're all counting by fourths. So we know we can start with 5, count by fourths, and end up with, we have to keep going because there's a 6 3/4. So we're going to go up to 7. Okay, so I've got to do this again. Keeps checking out on me. All right, so I have already created the line plot just to save some time, and so you don't have to sit there and watch me do it. So once again, we talked about starting at 5, ending with 7, and counting by fourths. You see that? Okay. So now I just have to input the data. All right. So we're going to go right in order so we don't leave anything out. So 6. Put a dot above the 6 to represent one of the bracelets that Brianna made. And then she made one that was 6 3/4, which would be right here. Then she made one that's 6 1/4, and then 5 3/4, and then 5, and then 6. We have another one that's 6 inches, and then 6 2/4, and then 6 1/4, and then another that measures 6, and then the last one is 5 3/4. So there we have all the data from this input onto a line plot. So is there an outlier on that line plot? Do you see a number that kind of is away from the other measurements? And I would say, did you say 5? Good job, because it is 5. These are all clustered together. This one's far away from the rest, so 5 would be the outlier. It's away from the others. Okay, we're going to try one more. And this one's just kind of a quick, easy little question. And here I have golf team tryout scores. Mr. Ardito would like that because he loves golf. Okay, so here is the golf team tryout data. It's already input onto a line plot. Everybody see that? Yeah. Okay, so there are the golf team tryout scores. One person, and it's in, I've divided each of these numbers into smaller numbers. So as you can see, it starts at 40, 41, 42, 43, 44, 45. So it jumps fives. But in between each five, there is, the little ones. So one person scored a 41, one person scored a 42, one person scored a 43, 3 people scored a 44, no one scored 45, and and so on. You can see it. So my question is there an outlier on that line plot? Yes. And did you say, it's probably hard for you to see these little dots, little lines, but it's 65, 66, 67. So all of you smart people in room 208 probably said 67, right? Good. Okay, so what you're going to do today is you are going to do pages 601 and 602, and I'll put this on Google Classroom. You're going to do numbers 1 through 7, and then if you're feeling up to a challenge, you can try number 8. It's kind of a higher order thinking. But, some of you might be up for the challenge, so go ahead and do it. All right, that's the end of this one. So you have yourself a great day, and I'll look forward to seeing your work. Okay, bye-bye.